007, 14007, right? Next we have the resistor, so it comes under basic. A basic resistor, say of 1 kilo ohm would be a really high volt resistance. So let's take a small resistance so that all of the voltage drop appears across the PN junction. Okay. We have to take ground, sources, ground, okay. Then we need something to measure our voltages. So let's take something like indicator. We have some indicator, voltmeter. Alright, voltmeter V. Let's take a voltmeter across the diode. It's similar to multimeter. We could also take multimeter, no problem with that. And ammeter. Ammeter V. Let's take it. Okay. In this circuit. I hope. Let's start connecting the resistor to the PN junction, to the ammeter, back to the negative terminal. So this is forward bias condition that we are trying to simulate. Let's connect the terminals of voltmeter across the diode. So we are ready to go. So this is like 12 volts. So if we start at 12 volts, we will directly get a drop in the beyond the cutoff cutting voltage. So the current will be quite high. Let's see what happens. See, the voltage drop across the diode is 0.825. Are you able to see? Is it visible?
Yes, sir.
Okay, so 0.8 volts, that is a forward bias across the junction, PN junction diode, and we have 0.224 amperes as the current, which is quite a large value, that is a 224 milliamperes for a diode circuit. If we increase this voltage, say we keep it to 25 volts and we resimulate it, let's see, current should increase. Now it has increased to 482 milliamps, that is 0.482 amps. So we want to just plot this VI characteristics for forward bias as well as reverse bias. So we'll take we could take a long cut by taking down these measurements one by one, or we could straight away go for the DC sweep function which is available over here. I don't know whether I think I have not explained it, so let me show it. This is an interactive button, and in that we have a DC sweep option. You see, in DC sweep option we change two parameters. One is the source voltage that we want to measure. So this source voltage is V1, that is this V1. We want it to vary from 0 to say 30 volts. Let's keep it 30 volts. And in increments of 0.5 volt, so it's all right. We'll be able to measure the graph. And the output, we have we want V and I across the PN junction. So V2, V3, which one of them is the requisite? I believe V1 is across R1, V2 will be across this. So let's take V2 and we need current across diode, so ID1 current across diode, and then we go to start. Let's see what kind of output we get. So you are able to see that green line corresponds to current and the red line corresponds to voltage. You see the voltage starts to saturate like 0.7 to 0.8 volts, and it does not go, the drop does not increase beyond that, whereas the current steadily increases as we increase the voltage, biasing voltage across the PN junction. So what we need some kind of representation that is familiar to us. We want this type of diagram to see, this kind of plotting. So let's do one thing, we export this data to Microsoft Excel, and then there we will be able to see it in a convenient manner. So over here on the top, you see there's an option, export to Excel. So using this export to Excel, we are able to export the data of current and voltage that we had selected to Excel, and later on we can plot it with respect to the each other, the VI characteristic. So let's click on this button. Let's export both the voltage as well as current data, and we press OK. Then we get an Excel file. You see, this is the voltage and this is the current. So 0.51, I believe the second, the D and E columns will suffice as our voltage and current. So let's copy it separately. And paste it, say here. Alright, minus 3.8 e to the power minus 39, that is 10 to the power minus 39, we can say it as 0. Let me just put down 0. Let's plot this. Well, we go to insert. In the insert option, there is this chart, scatter chart, scatter plot, and then we select the scatter plot. You are able to see voltage versus current. We believe it's inverted, right? Do we need something other way around? So let me just delete this. We need voltage across the diode, not the source voltage. So I apologize. We need the voltage across the diode, and we paste it over here. Right? So this corresponds to 0. And we plot this curve by using insert, then going to chart, clicking this. Do you see what you need? So this is the familiar graph that we expect. You see, x-axis is voltage across the diode, voltage, bias, forward bias, across diode and let this be the forward current. So satisfied with this graph, let's go for the reverse bias. See, for reverse bias, our range of voltage should be very high. That is, reverse bias should go up to say 1100 volts, because we need voltage beyond the breakdown voltage. The breakdown voltage of the PN junction that we have taken, 1N4007, is 1000 volts. So reverse bias, let's take it. Let's close this. Let's take a fit. Let's just change the biasing. So first let me off this circuit and let me just is it visible? No. Let me take a screenshot. Let's copy this data and paste it over here. Alright, visible? Alright, so let's go ahead with the reverse bias. Okay. Let's rotate this component by using Ctrl R. Let's connect. Let's connect. Now let's start uploading this DC sweep. Go ahead with DC sweep. We have to change two parameters. One is analysis parameter and one is output. In analysis parameter, let's have a start value of 0 and ending value of say 1200 volts minus 1200 volts. No, 1200 volts, because we have just changed the polarity of diode. Let the increment be as it is and let the output be as is. So let's go ahead and run. So this is the transfer characteristic that we got. Let's go ahead and paste this data into Excel by using the export to Excel function. Let's take both of these and OK. In sheet 2, we got the data. So the second column is for voltages, reverse bias voltages. So you see the reverse bias voltage, when we increase the reverse bias voltage to beyond 1100, the voltage drop across the PN junction is stuck at around 1100, which means this PN junction has a reverse bias breakdown voltage of 1100 volts, beyond which huge amounts of current starts flowing between the junction in reverse bias. So let's copy it to a separate line. Stay here. Let's multiply it with -1 since we need reverse bias. So for that we take an empty cell, we write down -1. Then what we do? We copy this data and we multiply this entire column. Shift down with -1. Right click, paste special. In the paste special option, we click on multiply and alright. Now entire column has been negated to -1. Then similarly we take down the current. Current is the negative direction. Copy this data and paste it over here. Select the two columns, go ahead with insert, go to scatter plot, click on scatter plot, and this is what we observe. This is the data we were expecting. You see, I believe there are lots of points, so we could delete a few points and we'll get a good view of the kind of layout that we expect. Alright, so you see at -1100 volts there was almost negligible current. Suddenly at -1100 volts the current starts, reverse current starts increasing rapidly, and we get this data. Let me copy this table into the original table. Copy. Let me put it here. See, reverse bias. And let me paste it over here. No, you can't paste. You can copy once again. Paste over here, and let me plot this with the help of insert, going to the chart, scatter with smooth line, or else we could go with the plane option. Okay, and then let's add the reverse condition to its x and y axis. Reverse bias cross dot and we have y axis as the reverse current. Alright, so Let me increase this plot in size so that it's visible. Let me move this to the right hand side further. Let me join these two. Let me bring it to the front. Bring it forward. So now you are able to visualize this graph the way we wanted. So now is it visible? The forward as well as reverse bias across the N junction. Let me just take a screenshot. Let me put it over here. Alright. So you have the reverse and forward bias VI characteristics. Forward bias VI characteristics, reverse bias, VI characteristics. Alright. So something like this, you would go ahead and simulate on your own. So were you able to install multi-sim on your systems? Or did you face any issues? The last time we had shared the link of multi-sim.
Yes, sir, I installed, sir.
Alright, so using simple tools, were you able to simulate simple circuits?
Yes, sir. Next class you taught that I did, sir. Last class, sir.
Last class. Okay, very nice, very good. And this is also pretty simple now that you have seen how to do this VI curve. It's a matter of few minutes and you will be easily able to simulate it. In the above notes, I have already pasted the steps because group A when had taken the lab, so most of the steps are enumerated. Let's just go through it so that you won't face any problem. We have selected 1N4007. Let me just highlight them, which items that we have selected. So we have selected 1N4007 diode followed by the DC power. Anything would do, even variable DC power, or there are numerous ways you can connect the circuit. Won't create any issues. You could also create this variable kind of voltage, DC interactive voltage. No problems, no issues. And this we have ground, so it's straightforward. Then we took last time I had taken 500 ohms of resistance. You could take any value of resistance as long as it is reasonable enough so that you are able to see most of the voltage drop across the diode. Then last time I had taken multimeter. This time I have taken voltmeter and ammeter separately. No issues with that also. Last time we had for the previous group I had mentioned these values manually, so it took a lot of time. But for you, it's I searched on the net. It's available quite easily. You could also search on the net. So this plotting of DC sweep, it gives us a convenient way to plot this curve on Excel without going into manual entry of data. You could also go ahead and change the minimum and maximum input voltage one by one, and you could measure the voltages according to this settings. Last time I have taken this multimeter and this circuit was straightforward, simple for forward bias or reverse bias, both the conditions. Then multisim, this is the link in case you need to install. So here's the link. You could go ahead and install it from getintopc.com. Here's the link screenshot where the setup takes 800 MB also, and it's very easy to install. You could go to YouTube and look for videos in multisim so that you can easily follow what I have explained just now. So it's nothing and quite easy to learn. I have pasted the links to YouTube videos also. You could search on your own for your convenience. This is the circuit that we took today, and this is the graph that we had exported using the export function. So I believe the export function is not pasted over here. So let me just breathe through it. Let me close this. Once we are done with this circuit, where do we go? We go to DC sweep analysis. So in case this toolbar you are not able to find, you can go ahead to simulate. Any simulate, there is analysis and simulation. There also you get the very same thing, the DC sweep. So let me take a screenshot of this section. Okay, enter Shift S. Here's the part. Then let me paste over here. Let me highlight that part. DC sweep function, very convenient. You can directly plot the data. Or else, if you do not see this DC sweep, just beside the simulate button, then you could go for the simulate toolbar. So let me take that screenshot also. Simulate. Windows Shift S. Okay. Windows Shift. Let me paste. Do we have the required? No, we do not have the actual thing required here. So logic for the mix up. Let me retake the screenshot. Alright. Paste it once again. So here in the simulate option, you go for analysis and simulation. There you will get that box in which you select DC sweep. So let me take a screenshot of DC sweep. DC sweep. Paste it here. Okay. Now it's visible. DC sweep function. You have to change the range for forward bias as well as reverse bias. Let's on it. For forward bias, what do you need the range? V equal to 0 to say 30 volt would be enough. And for reverse bias, you have V1 from 0 to 1200 volts. Don't forget to invert the junction, invert the connection. Then for output, what do you need? For output, you need the current and voltages. So let me take the screenshot. Let me paste it over here. Okay, so for current and voltage across the diode, you have to just add them up and then you click on run. Then what happens? You get a graph which you don't need, but you need its export characteristics. So you do not need this graph, but you need this export function. So let me take a screenshot of this entire thing, paste it over here. Let me shrink it a bit. Alright, let me highlight this part. We need this export to Excel function. Then go ahead to export. There you have to select both the options of current as well as voltage. So let me take a screenshot of voltage and current and paste it over here. Alright, here voltage and current, then click on OK. Then you have Excel open up. So there's your Excel data. Then what do? You just use these two current versus voltage versus current. You paste it in a separate place. And what do? You go to insert and then plotting. So say, let me just demo it over here. Suppose we want to plot the graph for this much data. So I select that data, I click on insert and then I click on chart. Let me take a screenshot over here. Okay. This one should be enough. Let me paste it over here. Are you following me? Okay. Here insert, scatter plot. I have taken this option. You must select the data also, but you need X and Y axis. So in the X axis you will take V. V, then I take those data over here, then select it and then go for scatter plot. That's how you do it. Alright, I believe it's clear enough. So any questions? We are done for today. Any questions? Any doubts? In case those who do not have laptop or desktop on their systems, instead of going for, yes please.
Sir, what will be the assignments? Is this what we should do?
Which assignment are you talking about?
Lab assignments.
I am not informed about any lab assignment. So if you have any information, please do let us know. But as far as I know, whatever we have shown in Multisim and this class, I will be sharing with you the PDF. So you could go through it once and you could search net for any relevant topics related to our lab. And once you just simulate this on your systems on Multisim, that would be enough. And once you are able to physically report to the labs, to the campus, then we may go ahead with the assignment system. As of now, we do not have any instruction. And this, those who do not have Multisim or those who do not have PCs, so for them it's very convenient to go ahead and simulate these circuits on your Windows, your browser itself. So if you have a cell phone, so just go ahead with the Multisim Live function. Let me show it. Let me show you Multisim Live, Multisim Online Circuit Simulator. Alright, so this is the online circuit simulator that you need. You just need to sign up for a free account. Go ahead with this multisim.com website, sign up for free. So let me just log in. Alright, so once you are logged in, you just create a circuit over here. So online you will be able to simulate the circuits, no need to even install multisim. So for those who do not have systems, this is a very convenient method. So let me just start off with this split function where you could see the input as well as output. Go ahead and put up a diode. Let me put a diode. We need forward bias characteristics. So let me put ground. Let me put source like DC voltage source. We need resistor. So we put resistor and let me connect this circuit. It's in wire. Similarly, other connection. Go ahead with other connection. Alright. Then we need VI characteristics. So we take voltage and current. Let me just place it before the diode. So we will get the voltage and current characteristics. Let me start off with this circuit. You see? Let me just pause it. See, this is the voltage which is across the V1, that is across the source. This is the current across the diode. And do we have voltage across diode? No. So let me change this topology. Let me first put resistor. Okay, so you could go ahead and first connect resistor, then followed by diode. Then you will be able to see the correct drop across the diode circuit. And you could save this for your own simulations. You could practice more using further tutorials available on this website multisim.com. So let me just take a screenshot and end this session. Okay. So we paste it over here. Windows V. Multisim online. Windows V. Or online simulator. Okay, I think that would be quite convenient for those who do not have systems. So, any questions? Shall we end today? Next lab we shall discuss quite a similar experiment. It will be related to Zener diode, just like we did for PN junction. We shall discuss how Zener diode operates, the VI characteristics of Zener diode. So it will be straightforward. I won't go into much details, and you will be able to see the similar curve. Only the difference between PN junction and Zener we need to emphasize, and how Zener is more practical than PN junction in real life scenarios. That we'll see next lab. Any questions, or shall we end now?
Excuse me, sir.
Yes, please.
Sir, I'm still not added in Microsoft Teams.
Alright, you're still not added to Microsoft Teams. The last time I had made my faculty in charge, so I'll just let him know once again. You just tell me your roll number once more. In fact, I have sent you a mail. Yes.
2004
2004
130.
130. 2004-130. That's your email?
Yes.
Alright, so I'll personally ask him once more, and he'll be able to join you. So thank you for letting me
Thank
know.
you.
Okay, have a nice day. Stay safe. Any more questions?